All right, so this is the video for problem number 2 on FRQ Friday number 8 in AB Calc. And again, I'm just going to jump right into the problem. So we've got a graph of G prime. They also told us that G of 0 is equal, that should be an equal sign, to 5. And they told us what the graph was made of, but we can see that. So A wants us to find G of 3 and G of negative 2. So if I want to find G of 3, and I know some value at some point for G, then to find G of 3, that should be an equal sign. G of 3 is going to be the value that I know, which is at 0, plus the amount of change or the amount of area accumulated from that x value that I know to the one that I want to know. So the area under the curve for G prime of x. So to calculate the area from 0 to 3, that's where my geometry skills come in. So what I see from 0 to 3 is I see a semicircle. So that, and then this triangle. So those two areas are what I'm going to calculate. So the semicircle would be 1/2. No, that's not a semicircle. That's 1/4 of a circle, a quarter circle. So 1/4 pi r squared. R is 2 there. Here's your center. Here's your radius. And then plus the triangle would be 1/2 base times height. The length of that base is 1. The height is 3. So then our calculations are going to be 5 plus, all this becomes a pi, and this becomes 3/2. So you could leave your answer like that, or if you want to, 5 is 10/2 plus the 3/2 plus pi gives us 13/2 plus pi. All right, so then we're going to do the exact same thing for G of negative 2. We start with that value of 5, and then we're going to integrate from 0 to negative 2 G prime of x dx. So let me erase what I had up here from G of 3. To go from 0 to negative 2 would be this much space. Now, remember that we have discussed the fact that integrals are directional. So when I'm measuring that integral, it is above the x-axis, but it's moving in a negative x direction. So I've got negative x's times positive y's. So that's going to be a negative 1/4 pi r squared. So that value ends up being 5 minus pi. So this part was worth 3 points. You got 1 point for recognizing that you needed to incorporate that 5 in, and then you got 1 point for the correct answer for G of 3 and 1 point for the correct answer for G of negative 2. All right, so then B. B wants the x-coordinate of each point of inflection on the graph on the interval from -7 to 5. I had more good answers than not good answers on this, so that's a positive thing. So we need to think about, if we're looking for points of inflection, this is going to be where G double prime either equals 0 or does not exist. So G double prime is the derivative of G prime. So we need to remember the fact that we're looking at the graph of G prime, and essentially we're trying to figure out where would this graph that I'm looking at right now have a derivative that either equals 0 or does not exist, but only, and then changes signs, okay? So for example, right here, the G double prime would equal 0 because that point is a maximum. Right here, G double prime is going to equal 0 because that is a place where the next derivative would not exist because that's a cusp right there, and it changes signs because we go from having negative slopes here to positive slopes here because we go from decreasing to increasing. And then right here is another place where G double prime would not exist because that's a corner, and we go from positive slopes to negative slopes. Now, So our answers are x equals 0, 2, and 3. So some of you may be wondering why -2 is not also a point of inflection, because that is also a cusp. But remember, the second derivative has to change signs there also, which means that the slopes at that point need to go from positive slopes to negative slopes. But if you look here, this is a positive sloped line, and then this graph is increasing right here. So it would be positive and continue to be positive. So that is a possible point of inflection at x equals -2, but it does not actually end up being a point of inflection. So I've identified my 3 places as x equals 0, 2, and 3, but then it also says to explain your reasoning. That involves some words. You have to actually write some words explaining why you chose these 3 points. So you could very easily say, because G prime changes between, so you could say between positive and negative slopes, or between increasing and decreasing at these points. Either of those phrases would be fine. And that's all that you would need to write for part B. So part B was worth 2 points. You got 1 point for identifying all 3 of those locations, and then 1 point for correctly explaining why you chose them. All right, then part C. Part C was worth 4 points. Part C also had a typo on it that we didn't catch till about halfway through the day. So some of you worked it as if the function was -1/2 x squared, and I graded yours according to that. But I'm going to work it without the typo in it. So the way h of x should have been described was as g of x minus 1/2 x squared. And then they want us to find the x coordinates for the critical points of h. So most everybody, regardless of you had the typo or the non-typo to work with, you understood that to find critical points, you needed to look for where h prime of x was equal to 0. So you begin by finding h prime of x. So reading that equation that I've underlined there, the derivative of g of x would be g prime of x, and then the derivative of minus 1/2 x squared would be minus x. You got 1 point for writing that right there. So even if you had no clue what to do after that, you got a point for writing that down. So then what we're looking for, if we're wanting this to actually equal 0, we're looking for where g prime of x is actually equal to x. So, what does that mean? It means basically where this graph up here, the y-coordinate matches the x-coordinate, is what we're looking for. Just looking at it right off the bat, I can tell that this is one of those places, because notice the x and the y are the same thing. So x equals 3 is going to be one of my critical points. Now the question is, do I have any other critical points? There are none that I can really identify visually, so I have to, because of that circle there. Like the lines are easy to look at. There's nowhere else on the lines where the x and the y are the same thing. But with that semicircle there, I need to kind of think about what that function is and when that function would equal itself, when it would equal x. So an equation for this circle would be, if it was the whole circle would be x squared plus y squared equals 4, because the circle has a radius of 2. So if I solve that for y, and then when I square root it, I should get the positive and the negative square root of 4 minus x squared. But since I only want the top half of the circle, I only care about the positive square root. So that's what that function is. So what I'm looking for there is, where are there any places that square root of 4 minus x squared is equal to x. Okay? Now you had a calculator where you could then actually just set these two things, graph both of them and see where they intersect. But if you were trying to solve this by hand, you would start by squaring both sides. So you would get 4 minus x squared equals x squared. 4 equals 2x squared. 2 equals x squared. And you would technically get x equals plus and minus the square root of 2. But we don't want the negative one because that would give us the underside of the circle. So we only keep the positive square root of 2. So that is another critical point. So your second point for part C came from identifying both positive 3 and square root of 2 as possibilities for maxes or mins. Then once you've identified your critical points, you can make a sign line with square root of 2 and 3 on them. And you would substitute values into your h prime, so g prime of x minus x. So for this left one over here, I would maybe do h prime of 0. So that would be g prime of 0 minus 0. To find the value for these g primes, you just go up to the graph and you look at the y coordinate. So when x is 0, the y coordinate is 2. So we get 2 minus 0 is 2, which is a positive value. Between square root of 2 and 3, you could use 2. So h prime of 2 would be g prime of 2 minus 2. G prime of 2, looking at the graph there, when x is 2, y is 0. So this is a negative value. And then for the last interval, we could use 4. So you would do g prime of 4 minus 4. And if you look at the graph, when x is 4, that was kind of hard to see, but I can do 5. Because 5, I can tell exactly where it is. So g prime of 5 is negative 1 minus 5. So what I notice here is this is the only place where it actually changes sign. So once you've done this work, you then have to identify, and it changes signs from positive slopes to negative. So we would have a max at x equals the square root of 2 because h prime changes from positive to negative here. And then you do actually have to say no max or min at x equals 3. So you do have to actually say you ruled it out, and you need to say why. So you would say because h prime of x is negative to both the left and the right. Of x equals 3. Okay, so you got 1 point for coming up with the equation for h prime of x, 1 point for identifying the 2 critical points, 1 point for justifying that x equals square root of 2 is a maximum, and 1 point for justifying why x equals 3 was neither a max or a min. And that gives you your total 9 points for this problem.